So let's talk about our first problem of that category. So we have been given two strings. Okay, let's say S1 and S2. Let's say your S1 is ABD and this is ADB. And what you have to do is you have to find the length of LCS. LCS means longest common subsequence. I have already told you what is a subsequence. So now you try to understand the meaning of this thing. Two strings, you have to find the length of longest common subsequence. Okay, what is the longest common subsequence for S1 and S2? So let's first understand the meaning of this thing. Let us list down all the subsequences of S1. There will be a lot of subsequences of S1. You will have A, you will have AB, and then you will have just B, and so on and on. So these are subsequences of S1. Now list down all the subsequences of S2. So you'll have A, you'll have B, you'll have AB, and so on and on and on. Now, out of all the subsequences, you will see that there are certain common subsequences, like AB is a subsequence of S1 also, and AB is a subsequence of S2 also. Now, out of all the common subsequences, I'm interested in the longest one. So now tell me, what according to you should be the longest common subsequence of these two strings? So it should be AB. AB is present here also and AB is present here also, and the length of AB is 2 units. But apart from AB, I can have AD also, like AD is a subsequence here also, and AD is a subsequence here also, but it is of the same length too. The question demands the length, so I can just output 2 and that would be my answer. So let's say your string 1 is AABCB and string 2 is ABAB. What is the longest common subsequence here? How about AAB? So AAB is present here and AAB is present here also. And you will realize that the length of this is 3. And there is no other subsequence of length greater than 3, which is common in S1 and S2. So your answer here should be 3. Yeah, instead of picking AAB, you could also have picked ABB. ABB. Right? So there also the length is 3 only. Cool. So can you write a brute force algorithm, a very simple algorithm that somehow figures out the length of the longest subsequence? So your approach will be super easy. What you can do is you can just create all the subsequences. Do you guys know how to print all the subsequences for a given string or for a given array? Can I use recursion to do this thing? Yes or no? Yeah, you can. So using recursion, you can generate all these things. Using recursion, again, you can generate all these things, and then you can try to find how many, which all subsequences are common, and you can gather those. And out of that, whichever has the maximum length, that will be answered. This is your brute force approach, which is totally correct. But it has a huge time complexity, because if you go ahead to generate all the subsequences, it will take you 2 raised to power n time, right? And if you store them, it will take much more memory. It's not an intelligent approach. So in immediately last problem, I had told you there is something which is called as elements of choice. Okay, elements of choice. So at every stage, in the last question for an element AI, there were 2 choices, either take it or you do not take it. Now, your decision influenced which state you moved on to. When I say state, when you took AI, then you used to move to I plus 2. And when you did not take AI, you used to move on to I plus 1. So your decision influences that from what state you will get to what. This is the entire game of DP. So you are at state 1. What is a state? A state is just a set of variables that you are passed to a function. So you are at state 1, you take a decision D, you move on to state 2. You take another decision D dash, you move on to state 3. You take another decision D double dash, you move on to state S4. Now, what are these decisions? Those are your elements of choice. They are influenced by how many choices you have. You perform all the choices, and then you will see you will move on to different states. So the exactly same kind of thing we'll try to do here as well. Let's say the two strings that we have are something like that. S1 is a string that ends with A, and S2 is also a string that ends with A. That is a common thing in them. Now, just tell me one thing. You want to figure out the LCS, I'll call it LCS, the LCS of this entire thing and this entire thing. Now, if the last characters are matching, can I say whatever will be the LCS of S1 and S2, that LCS would also end with A? Can I use my common sense and say this thing, yes or no? Right? Because common subsequence is made up by picking common set of characters. See, if let's say you have S1 and S2, now if I introduce a Z over here and a Z over here, then who stops you from including this Z in your current answer? If your current answer is AAB, include Z at the end. So it means that if at the end the characters are matching, then that character will definitely contribute to your answer, which is your actual LCS. So what does it mean? It means that if the last characters are matching, then the contribution of this last character will be there, which is 1 plus something. Now, what is that something? So that something can be written as the LCS of remaining S1 and remaining S2. See, what was the LCS of remaining S1 and S2? You said it was ABB, which had a length of 3 units. So if you add 3 to this 1, which is because of this Z, you will get 4. And what is that 4? That 4 is the LCS of these two big strings. So my intention is to say that if I have a string S1 and a string S2, let's say its last character is at index I, the last character here is at index J. Now, if there is a situation where S1 of I equals S2 of J, if this is the case, it means for sure this last character will be there in my actual LCS. And now all that I have to do is I have to focus my attention to find the LCS of remaining strings. So in this case, I can say that, hey, LCS of I comma J, here I and J denote the last characters of S1 and S2. This is 1 plus LCS of the remaining part, which is I minus 1, J minus 1. So this is the first equation that we have come up with. Now, what is this I and J? So this I denotes the part of S1 from beginning till I. Similarly, this J denotes the part of S2 from beginning till J. Now, if I have told you what is LCS ij, you can figure out what is LCS I minus 1, J minus 1. LCS I minus 1, J minus 1 means that here we are talking about the part of S1 from beginning till I minus 1. And here we are talking about part of S2 from beginning till J minus 1. And now we are able to say that, hey, the LCS of a larger combination of strings is dependent upon the LCS of smaller combination of strings. So what is this? This is exactly a recurrence relation. Yeah, it has a condition that you will apply this rule only if the last characters match. So now we need to come to the situation when the last characters do not match. Okay, what if the last characters do not match? Let us take that case. Let's say you have got S1 ending with A and S2 ending with B. Can you tell me what to do in this scenario? This is your ith character, this is your jth character. What to do here? Will the same recurrence be applicable for this scenario where S1i and S2j do not match? The answer is no. Why? Because of a very simple reason that A and B do not match against one another. So their match cannot make a contribution. In fact, it is correct to say it is incorrect to say their match because they are not matching only. So what to do? So I'll tell you one very interesting thing that people do. People kick out this thing also, and then they say that, hey, now just focus on finding the LCS of the remaining parts. So in this situation, they say LCS of ij, I have already defined what is LCS of ij, which is super important for you to understand. They say LCS of ij is equals to LCS of I minus 1 j minus 1. That's it, they say. Is it correct to write this thing when the last characters haven't matched? The answer is no, it is not correct to write this thing. And I'll give you an example. Let's say you have S1, which is like ZYX A, and you have S2, which is ZX, let's say ZX A B. Who will tell me the answer for this case? What is the longest common subsequence over here? It is ZXA. Now you can see that here the last characters are not matching. If the last characters are not matching, and you will say that, hey, the LCS will be the same as LCS of this much part. So now tell me, what is the LCS of this much part, which I have boxed? It is ZX. It is ZX. ZX is present here as well as here. But what is the LCS of the actual two strings? The LCS of the actual two strings is ZXA. ZXA. So it is not correct to say that if the characters are not matching, then only figure out the LCS of remaining part and that will be your answer. It is not correct to say that. And the reason behind that is very, very simple, because who knows, this A could match some other A. This A did not match against this B. This A did not match against this B. This is totally okay. But this A could have matched some other A that could have lied before it. Similarly, this B could have matched some other B that could have lied before it. So it means that, hey, I and J do not match together. But this I, when taken into account, can match with some other B that comes before it. So what I'll do is, when I keep my I over here, I'll move my J by 1 unit. So writing this means you are trying to now figure out the LCS of this much part with this much part. Because this A should be given an opportunity to match with some other A that could have possibly lied before B. Similarly, a different style could have been that who knows that this particular B could have matched against some other B. So keeping J intact, you are moving your I and thereby giving this B a chance to match some other B. So this can be expressed as LCS of I minus 1J. The only difference between this and that is here your I is intact and J has moved. And here your J is intact and I has moved. Here you are giving an opportunity for A to match with something, and here you are giving an opportunity for B to match something. And you do not know what will match because you do not know what the future is. So you are exploring both these opportunities, but you do not know where the solution will come from. What if the LCS of I comma J minus 1 is 3 and LCS of this is 5? Then you would want to take the max of these two. So whatever is the max of these two things, that would be your answer. So now it means that, hey, if the last characters match, then LCS of ij will make this call. So imagine there is a function func ij. So if S1i, S2j match, then func ij calls func I minus 1 j minus 1, adds 1 to it, and that is your answer. But if the characters do not match, then f of I comma j will call two methods. First is for ij minus 1 and second is for I minus 1j, and whatever is max of those, that would be your answer. When you go ahead to code it, you will also have to think about the termination condition. Now, how is your I and j changing? So let's say the size of this string was 6 and the size of the other string was 4. Now, if this condition is true, let's say for the last indices, if this condition was true, then it will change to 5 comma 3. Your I comma j becomes I minus 1 j minus 1. And let's say now, if at 5 comma 3 this condition is true, then there will be two calls that will be happening, like 5 comma 2 and 4 comma 3. But you will see that the value of I and j are reducing over the time. When they are reducing over the time, eventually it can happen that your I becomes minus 1. Okay, when your I becomes minus 1, that means the part of S1 that you are considering is empty, because I denotes the prefix from 0 till index I, right? So if I is -1, that means there is no prefix in S1. That means an empty prefix. Similarly, if j is -1, then it denotes S2 is empty. Do you understand these things? What is the physical meaning of I being -1 and what is the physical meaning of j being -1? Now answer me one very simple question. If I ask you that, hey, tell me the LCS of first string, which is something like that, and second string, which is empty, what will be the LCS of this? It will be 0. Because if either of these two is empty, then my answer will be 0 for sure, right? So my termination condition can be very simple. My termination condition would say if I is -1 or j is -1. If any of them is -1, or you can say if any of them is negative, whatever you are comfortable writing, then you would return 0. Because if either of these conditions is true, that means one of the substrings is empty, and LCS of empty comma something is 0 for sure. So that will be your termination condition. And then if this condition is true, you will make this call, otherwise you will make that call. So let's say there is an LCS method. Here you pass I and j, which denotes the indices. So if I negative or j negative, return 0. Otherwise, you need to check which condition is true. I mean, you just check if the last characters of S1 and S2 match against one another or not. If they do, then you have to return 1 plus LCS of I -1, j -1. Correct? Otherwise, you have to return maximum of the two calls. The first call is ij -1, and the second call is I -1 j. That's it.